Right, Bas, welcome once again. As I had promised, I've gotten squared some time to go through this together with you. Don't forget to subscribe, to hit the button, hit that bell, try to share, and also try to drop your comments. So today we look at how to represent linear inequalities in one and non graphically as you had requested earlier. Now there are principles that we must follow when we are dealing with this. And those are the principles that we want to go through so that you are versed with them. Now, let's just get an example of a linear inequality where you're supposed to graph, but it's supposed to have only one unknown. So let's just have it. Let's have, say, x plus 2 is greater than, let's say, greater than 3. Now, let's say we have this and you've been told to graph it. What do? First of all, we must ensure that there is a value that we are comparing x with it. So there is the value that we are comparing the unknown with it. So what we do in this case, we have to move this particular number that has an x with it to the other side. So just as we did in the other classes, we shall have now our we shall have our x is greater than, of course, these 3. This one now moves to the other side. So it will be subtraction. We shall subtract both sides because it has been added. So we shall subtract 2. And therefore it means x is greater than 1. So you need to graph this. What do? Now there is one thing that we must know and be very much versed with. When you are graphing inequalities, we use two types of lines. One, we use continuous lines, and two, we use what we call dotted lines. Now, at what circumstance, at what case are we permitted to use what we call the dotted lines? Now, if your inequality is greater than or less than, if our inequality is either greater than or less than, we use dotted lines. We use dotted line. Now, if the inequality is greater than or equals to, or this is less than or equals to, we use a continuous line. Continuous line. So we need to know that. Now, why are we using continuous line? Because the number represented there, the number that we are comparing it with with the unknown, that number that is there is part of a solution of what we are representing on a number line, on a graph, that is. So let's see what we can do. We have this one, and therefore we want to graph this. So this is our Cartesian plane. Let's have our Cartesian plane. That is our Cartesian plane. And we want to graph this. So our y-axis. This is our x-axis. Let's say this is 0. This is 1, 2, 3, and then 4. Here we also have 1, 2, 3. Here we have -1, -2, -3, -4, and so on. Here we also have -1, -2, -3, -4, so on. So this is our Cartesian plane. We want to represent x is greater than 1. Now what do we do? First of all, you assume, you represent the greater than sign. First of all, it becomes, we want to draw the line. So we draw the line x. This is x is greater than 1. So draw the line. You draw the line. Which line? You draw the line x. This one becomes equals to 1. So this is the line that we have to draw. X equals to 1. Now, x equals to 1, it means as the values of y change on that line, the values of x are retained to 1. The value of x is just, stagnant on y. As much as y values are changing, x values are not changing. So which line is this? This should be a line that passes through 1, that is 1. And then 2, it's a line that is parallel to the y-axis. So our line will be this line, of course, using a ruler. Just a minute, you can pause. Yes, this is our ruler. Sorry for that. So we have to draw 1. We said it is not continuous line, it is dotted because 1 is not part of the solution. So we have to draw a dotted line that way through 1. So this is our line. This line is x equals to 1. So the values of x here, if we have to pick any point, let's say here, the coordinates of this point at this particular part where we are will be 1, 2. 1, that is x, 1, y will be 2. So any point that you pick on the line will just have x values equivalent to 1. So what do we do now next? We have already drawn the line because we have identified it. We know it is dotted. Why? Because our inequality is greater than. So we have, for us to know where to shade, we normally shade the unwanted region. Now, how do you know the unwanted region? Unwanted region is that region that does not satisfy the equation of the line. The equation of this line is not satisfied. The inequality cannot be satisfied, by any point that we choose on either side of the line. So whichever point that you pick, if it does not agree with the inequality sign, then automatically that becomes the unwanted side. So let's see. Let's pick any point on the left and the right of our line, as we always do. So let's choose maybe this point here. This point. You can pause and then try to write the coordinates of the point. The coordinates of the point will be this point. Let's say this is point, maybe P or whichever, this point here. So the coordinates are x is 3, 1. 3, 1. So if we pick this point for the value of x and try to replace it in our inequality to see if it agrees, then we shall know which side is the wanted and which one is the unwanted. So let's do it. X here is 3. So 3, if we place 3 here, let's say our inequality is x is greater than 3. So we say maybe x here is 3, then the sign here is greater than 1. Does that agree? Is 3 greater than 1? Correct, yes. So this is the wanted side. So once you get the wanted side, what do? You shade the unwanted side. We shade the unwanted side. That is what we do. We do the shading. We shade the unwanted side that way. Beautiful. So this is the unwanted side. Why? Because the value of x, because with a coordinate, we begin with x, then y. So any point here, even if we take a point here, 2, 2 or 2, 3, if we put here, it will be greater than 1, and therefore this is the wanted side. Now if you pick any side on the left hand side of the line x equals to 1, let's see, maybe any point beyond this area here, let's say maybe this other part, the part like here. So this is negative 2, comma 2, negative 2, comma 1. I mean this point here. Then you try to fit it into the inequality. So our inequality is x is greater than 1. We have picked our point where x is negative 2. So we replace x with negative 2. What shall we get here? Let's see. So this will be our x is negative 2. Then we have greater than 1. And then we ask ourselves, is that realistic? Is it realistic that negative 2 is greater than 1? Your conclusion will automatically be that this is not possible. So because this is not possible, it does not satisfy any point on the left of the line, does not satisfy the inequality that we have. And therefore, this one becomes the unwanted side. And therefore, we shed it. All right? Now, what happens if we are going to have maybe an inequality whereby we have to draw a continuous line? We can pause and also try to look at the example that we have to put down. All right, now we have, I think you did a pause, and we have this case here whereby y, we're saying y is less than or equals to 3. So suppose we have to graph this. What do we do? Y is less than or equals to 3. What do we do? So we are supposed to know, first of all, the line that we shall draw. So the line that we have to draw here, draw the line y equals to 3. That is the line that you will draw. Y equals to 3. So which line is this? Y equals to 3. Remember when we talked about x equals to 1, we did draw a line that is parallel to the x-axis. So this one will be a line where values of y will be retained to be 3 as x values change. So which line is this? That should be a line that will be drawn through 3. As it crosses the y-axis. So with our ruler again, we have to draw that line. But before you draw it, you have to ask yourself, will the line be continuous or dotted? So from what I explained earlier, you can guess. What will it be? We said that if the inequality sign is greater than or less than or equals to, greater than or equals to, you draw a continuous line. So here we shall have to draw a continuous line through 3, that way. So on this line, as the values of x, if we pick any coordinate on the line, you will realize that the values of y will be constant as 3 as the values of x changes. If you pick, let's say, maybe a coordinate here, this will be, this will confuse you. Here, let's say at this point. The coordinates of this point will be 2, 3. Here, we shall have 4, 3. Then again, at this particular point, we shall have 1, 3. So you'll realize that the values of x are changing, but the values of y are not changing. So what do we do in this case? We said this is the line that we have to draw, and it is continuous. Why is it continuous? Because part of the y value is part of the solution. It will be part of the solution because we have an equal to. So it is part of the solution. Now, next is to know how to shade it. Which side will you shade? And I said earlier, for you to know where to shade, just pick any point. Either now this one, now that it is parallel to the x-axis, pick any line above or below it. Okay? Believe you are following. Above or below it. So pick any. Let's say we have, let's say maybe here we have 4. 4 is somewhere here. So let's pick just any point. Let's say maybe we pick a point here. This one is 4. No, sorry, 3,4. And we can also pick any point below here. Let's first of all deal with this. So our point there is 4,3. Now 4,3 as our point, we want to now try and bring it back into the inequality to see if it agrees. And what are we basing on? The value of y, because we are saying y is greater than 3. Y should be greater than 3. So our y here is 4. So now we shall come and say, because we have y is, less than or equals to 3. So we replace y with the y values, which we are 4. So 4 is less than or equals to 3. That is what we are getting. Is it true that 4 is less than or equals to 3? No, the answer is no. So because we are saying no, once you say no, that is the area to shade. Now, let's pick another point. Let's say maybe a point below it, and maybe we have a point like here. Let's say we have maybe a different point even at this point. So we have point this one here, that is 3,2. Have 3,2. The value of y here, this is x, this is y. So our y is 2. Then we come and say y is less than or equals to 3. So here we replace. We have 3,2. This is our y, this is our x. So we are saying 2 is less than or equals to 3. Is it true? Yes, it is true. 2 is less than 3. So this satisfies the equation. Therefore, we shade the unwanted region. This is the unwanted region. This region is unwanted because it does not satisfy the inequality. I hope you are benefited and you continue doing more practice. You can pause the video and maybe do y is greater than or equals to 4. Can try that one out. Can do you can send your comments the comment section. Welcome again. Nice time.